we're going to first talk about algebraic expressions, and then we'll get into equations in a little bit. So an algebraic expression is some stuff on your paper that's got numbers and variables in it, but no equal sign. So an expression is not an equation. It will not have an equal sign. And the first type of expression that we're going to talk about is a term. And in particular, we need to know that only like terms may be combined using addition or subtraction. Like terms are those that have exactly the same variables raised to exactly the same powers. Some more vocabulary here. The numerical factor in a term is called the coefficient. Let me give you an example of a term. So a term, what's a term? Here's an example of it. A term is a product of a number and one or more variables, and the variables could be raised to power. So 2xy, that's a product. It's a multiplication of a number and one or more variables. That's what we call a term. Here's another example. X squared, x squared, that's a term. Even though you don't see a multiplication, you can think of it there being an invisible 1 multiplying the x squared. Here's another one, minus 1/7 x y cubed z. Again, that's a term. It's a product of a number and one or more variables. What terms do not have between them, between the things in the term, you will not see multiplication or addition or division. It's just things that are multiplying each other. And the numerical factor is called the coefficient. So in this term, 2 is the coefficient. In this term, x squared, the invisible 1 is the coefficient. And in this term, minus 1/7 is the coefficient. And again, like terms are those that have the same variables raised to exactly the same powers, and those are the only ones that we can combine using addition or subtraction. So let's use that idea to simplify this expression. 3x squared y plus 5xy squared plus x squared y minus 7xy squared plus x squared. So there's a lot of stuff on there. If possible, I'd like to condense that down, which is called simplifying it. And so I'm going to look for like terms. So those are terms that have the same variables. Now let's see. These first 4 terms all have both x and y, but you have to have the same variables raised to the same powers. So for example, these first 2 terms are not like because this term has x squared, this term has x just to the invisible first power. But if you go one over further, there's an x squared y term, so I can combine that with the 3x squared y. And the way you combine terms is you combine their coefficients. So actually the way I think about having 3x squared y plus an x squared y is I think of it as having 3 of these things plus 1 more of these, because there's an invisible 1 there. So how many of these things do I have? Well, I've got 4 of them. I have 4 of those x squared y things. Notice the exponents do not change. I still have x squared. I don't suddenly have x cubed. And I still have y. I don't suddenly have y squared. I'm not multiplying, I'm adding. And when you're adding, the coefficient tells you how many of those things. And the whole blob of variables and exponents in the term, you should think of as a type of thing. It's like I have 3 oranges plus 1 more orange. What do I get? I get 4 oranges. I don't get 4 grapefruits. The thing doesn't change when you combine things by addition. You just have more of them. And the coefficient tells you how many of them you have. So similarly here, 5xy squared minus 7xy squared. It's like having 5 oranges minus 7 oranges. And I know you can't have negative 2 oranges, but in algebra we can have negative 2 things. minus 2 of those things. What are those things? They're those xy squared things. The thing doesn't change just because you took some of them away. So I combined those two. And then last, the x squared, there's no one like him, so he just stays as he is. Okay, and one more example of simplifying an expression by combining terms. Notice there's something going on here that that's a little different than in the previous example. I've got a bunch of stuff, a bunch of terms in parentheses. Now, parentheses are like brick walls. The stuff inside the parentheses cannot see the stuff out here. This stuff doesn't even know about this stuff. They cannot see each other. So, for example, I certainly cannot combine the x squared terms right now, because this x squared cubed term, this x cubed term is outside the brick walls. This x cubed term is inside them. They can't combine. They can't even see each other, much less combine into a single blob of x cubed things. Similarly, these x's, I cannot combine them. Yeah, they're like terms, but this guy's inside a building that's got brick walls. This guy's outside. They can't get together. What we need to do before we can do any combining is knock those brick walls down so that everybody can see each other and walk around and combine. How do we knock these brick walls down? How do we get rid of them? Well, notice that what's going on inside these is additions and subtractions. What's happening outside is a multiplication. So I'm going to think of that as minus 3 times the parentheses. And in the parentheses, I have additions and subtractions. That's exactly what the distributive property is for. I'm going to distribute that minus 3 into each term in the parentheses. So I'll have 2x cubed plus x. Minus 3 times 4x cubed is negative 12x cubed. Then minus 3 times negative 2x squared is positive 6x squared. Negative 3 times negative x is positive 3x. And negative 3 times positive 5 is negative 15. So the distributive property of multiplication over addition or subtraction gets rid of parentheses for you. That's probably the main thing we use it for in algebra. Now I can combine like terms. Everybody can see each other. They're free to walk around and combine. 2x cubed minus 12x cubed is negative 10x cubed. I'm going to do this in order of the exponents so my answer comes out nice. So I'm going to deal with the x squareds next. Well, this is the only x squared, so no one to combine him with, so I'll just write him down. Next down I have the x terms. I've got 1x plus 3 more x's. That's a total of 4 x's. And then the constant term, in other words, the term with no variable, negative 15. There's no other constant terms, so I'll just write him down. Okay, and that's all I can do, so we're done with that one.